Let's start with another concept of object-oriented programming, and it's called abstraction. So, why is abstraction important? And what is abstraction? So, it's the process of defining a simplified model of a complex system, focusing on high-level functionalities while hiding the intricate details of implementation. Okay? It also allows users to interact with an object or system through a well defined interface without needing to understand underlying complexities. So let's understand this with an example, and we'll get to know why an abstract method is important, right? So you have something called a vehicle, okay? This is your vehicle. Let's take it as a class. The class vehicle. Okay. And then after this, you have a method. Okay. Engine. So let's keep it as engine information. So engine info. Put in the self. After this, we print. This is a V8 engine, right? So this method here prints the statement. Okay. And then it has more methods like def wheels self. Let's give pass for now. Def lights stuff. Great. So this is our parent class. Okay, for in the sense. And if you have a child class, so the vehicle is a car. Let's keep it as a class car of vehicle. And now this parent class has hundreds of attributes, okay, hundreds of methods or more they can have, okay, and uh, you need all the class instances, or I mean all the child classes, to have some methods compulsorily, right? So in this set of methods, I need all my child classes to have this wheels method. So that is where we use abstraction. Okay, so to use an abstract method, you will have to import it. And for that, we will do ABC import capital ABC and our abstract method. It should be abstract method. Okay, so from ABC, you import this and this, right? This will act as inheritance for your parent class. You put ABC here, and for this method, which you want it to be abstract, you place a decorator at abstract method. Now, this thing, wheels, this method right here, is an abstract method. We did something similar for static method also. So in the same way, now it's an abstract method. If I call my init class self, comma, name, and then self dot name is name. Okay. Now I'll just have it like this, and we'll create car1 c1 car of name. We'll name the car as 4 wheels. Great. So when I create this class instance, as you can see, I have given all the parameters needed. For now, let's just comment this out. It's commented. So this code doesn't work. And now you can see it works. But as soon as I put this back on, you get this error. Why? Because this method needs to be implemented in all the child classes of vehicle. Okay, so I need to be implementing wheels, self. Here, let's print 4 wheels. Now the method works perfectly. And if I give C1 dot wheels, 4 wheels. In the same way, if I take this and place it to another method here, see, I get this error. It even needs for lights. So all abstract methods in your parent class will be needed to be called in this child class, right? If you have another child class, okay, if you have a class called bike, which has inherited its methods and attributes from this vehicle class, you need to be calling all the abstract methods. Or when you create a class instance for the bike class, it won't work. You'll get the same error, right? So that is why abstraction is a super important concept in object-oriented programming. And you can also see why it's super useful, right? And after that, we will learn about the second or the next feature in object-oriented programming, which is polymorphism. It's the ability of different objects to respond to the same method call in different ways, right? So this allows a single interface to be used with various underlying forms. So let's see this with an example. So polymorphism is of 2 types. One is overriding and the other one is overloading. And Python doesn't support overloading, but we can also come up with a small logic that is not overloading, but it's similar to it, but it is actually not, because in Python, overloading is not actually possible. And if it's necessary, there are some ways which we have already done once, which can be useful to just get the same results as overloading in other languages. So coming on to overriding, overriding is in which you have a method in one class and in the other class or your child class, you call it in the other way, okay? This method wheels, when called, it doesn't do anything, it's just passed. But now we are calling it in our child class and making it to print 4 wheels. So now this method is being overridden by the child class to be to print this 4 wheels. So that is overriding. So in an example, if you have a fruit class and there's a method called name, okay, this method prints a, and you also have another class called apple, and apple class is a child class of the fruit class, and here we have our name method like always, and here we are making it to print pay. So now this name method is being overridden in the apple class, right? So that is polymorphism overriding. Also, you must know that it must be in inheritance, right? So if this is just another class and these two are independent and you call it like this and like this is not overriding. You need to be having a parent-child relationship, okay? Or any form of inheritance works fine. And coming on to overloading, let's take the same example. In overloading, what we want is, so suppose this has no parameters. We have another method in the same clause, but it's of the same method name. And here we give a, and let's just give pass right now. And here we'll have name, the same method with self and a comma b. So in other languages other than Python like Java, C++, overloading means that when you create a class instance, so pass. So if I create f1 is equal to fruit, okay, now this is your class instance, right? If I call f1.name, just like this, it should be putting in this method. If I call it with just one parameter, a, it should be running this method because it takes in one parameter. If there are two parameters mentioned, it should be running it with this method, right? But in Python, let's just see, we will give it without parameters. It shows missing two arguments, a comma b. But if I take this and put it at the top, now we choose just a single parameter. So Python, instead of taking the overloaded method or according to the number of parameters, it's taking the last method, which is of the same name. So that's why overloading is not possible in Python. But the workaround for that would be using the args and quarks, right? So if you have name, self, comma, star args, we learned this in functions. Now we are using this in methods. So print args, right? If I give it like this, I get an empty tuple. If I give a, now I can use this a. If I give more than one, see, according to the number of parameters, it's going to put it in this, and you can use those many number of parameters in your code. But what is the problem with this? According to polymorphism overloading, according to the definition, you must be having multiple methods of the same name and different parameters. That is overloading. This is not overloading, but it is almost similar to overloading. So that's how you can get overloading in Python. And with that, polymorphism is done. So what are the two things? Overriding and overloading. Great. So with that, let's move on to composition. You might not have seen this topic in most of your object-oriented programming in other languages or even in Python, but this is something super useful, and it comes into the advanced side of object-oriented programming, but it's not hard, it's super simple if you know what it is, right? It's a design principle where class is composed of objects. Objects in the sense class instances from other classes. Till now, we were taking parameters, right? So we give self, comma, name, comma, age, like that. But instead of giving variables, so these parameters, they are given a string value, integer value, float value, etc. We will give them a class instance instead. Get what I'm saying? We'll see it with an example. And when you give a class instance, you must know that in inheritance we had a is a relationship, and in composition we will have has a relationship. Okay, so let's see it with an example. Great. So let's take a class, my bad, class called engine. Okay, and here we will have a method called start, and we will print starting. Okay, and here we'll also put another method called stop, and we'll print stopping, right? After this, we have another class. In this class, we will call the instance of engine. So it's a car, and then there's no need of single inheritance here. We will see how. And here, you need to have class car def init self, comma, let's give a name, wheel, engine. Okay, this engine must be the name. This can be anything for now because it's just a parameter, but to this parameter we will be assigning a class instance, right? So you must make sure that this is a class instance. Let's see it. And self dot name, even for the class instance it's the same thing. So self dot wheels is wheels, and self dot engine is engine, right? It's similar to all these parameters. Self dot engine is engine. We have another method called def, and we will key within the self. Oh, we forgot self here. Self. Okay, so self, self, self. And here we will have self dot engine, okay, which is this dot, okay, dot. Now self dot engine actually refers to this parameter here, which we will assign to a class instance, and when you type in this it's going to call this method. So to get that we need a class instance. E1 is engine. Okay, now we have a class instance, no problems there. And then for our car, let's name it as C1 is car of name, let's name it as Audi, 5 wheels, there's a wheel in the trunk, so 5 wheels. And then here we'll have E1, right? E1 is your class instance. Wheels is not defined. Okay, my bad. Because there is no S, I put S here. That was wrong. So yes, we have our C1 class, and let's give C1 dot key. That is the method here. Key. Say you get starting. But this starting is not from this, it's actually from this. If I put here stop, stop, see, I get stopping. So that is composition. In composition, you can have class instances as your parameter for another class instance. And you can use that class instance inside a method of the other class. Like in this case, we just simulated the engine stop by calling the key method, right? So while going through projects and all, if you find something that can use composition, be sure to use it, as it is useful in some cases, as in this case, when we turn on the key, or this can be key off in the sense, so key off, and it's automatically going to run the stop method of the engine. And you can configure your output in the engine itself. What must be done when the key is off and the engine is going to stop, so all the codes can run here. So that's why composition is super helpful.